Our main objective today is to learn how to use a normal distribution curve. But first we're going to look at the frequency polygons formed by our histograms. If you smooth out the lines to a curve, you can begin to see where the normal distribution curve originates. When data is symmetrical about the mean, it forms a bell-shaped curve called a normal distribution. The curve for a normal distribution is based on the mean of the data and the standard deviation. In a normal distribution, the mean is at the center of the data, or maximum point of the curve. Each of the other areas of the curve are plus or minus standard deviations. For example, our mean is the center. The next line out is the mean plus one standard deviation. The next line back to the left is the mean minus one standard deviation. The next line out to the right is the mean plus two standard deviations. The next line back to the left is the mean minus two standard deviations. The next line out to the right is the mean plus three standard deviations, and to the left is the mean minus three standard deviations. We typically only go 4 standard deviations from the mean. According to a normal distribution curve, 99.99% of the data will fall within 4 standard deviations. As a matter of fact, let's look at the percentages within each standard deviation. Within 1 standard deviation, there are 68.3% of the scores, or numbers, pieces of data, will fall in this section right here between those two spots. That's 68.3% of the data. Within 2 standard deviations, that number jumps to 95.5% of the data happens within 2 standard deviations. That would be 95.5%. That means going out that much farther only adds on 27-ish%. Within 3 standard deviations, we end up at 99.7%. So 99.7% of the data is going to fall between 3 standard deviations, 3 to the left and 3 to the right. Again, as I said before, 99.99% will fall within 4 standard deviations. Well, how do we do this, and how do we draw the normal distribution curve? The first thing we have to do is find the mean, x bar. The second thing we have to do is find the standard deviation. I've put the formula on there for you. And then we just need to add and subtract the standard deviation from the mean. Here's a sample problem with most of the hard work done for you. They've already calculated the mean, and they've already given us the standard deviation. So the first thing we would do is we would go to the maximum point of our curve, draw a line straight down, and label that with the mean, which was 565. Now we're going to try to divide the sides up into 4 equal sections. So there's 1, 2, 3, 4, and 1, 2, 3, 4. Now to label these, we have to add and subtract the standard deviation. The standard deviation was 5 grams, so basically we're just counting by 5s here. So 565, 570, 575, 580, and the 4th distribution or standard deviation would be 585. Counting backwards, we have 560, 555, 550, and the 4th standard deviation would be 545. Now, let's actually apply this to the problem. Suppose that 6,000 boxes of cereal were taken from the assembly line and checked, and we're supposed to estimate how many boxes fall within the different intervals. Our first interval is 560 to 570 grams. Well, 560 to 570, if you look at it, that's 1 standard deviation to the left and 1 standard deviation to the right. that means we're falling within 1 standard deviation, or 68.3%. If we calculate 68.3% of 6,000, so we're just going to take that, multiply it by 6,000, it works out to about, oops, I think I only multiplied by 0.68 instead of 0.683. Check the math. It's somewhere near 4,080 boxes though. The next thing we want to look at is 555 to 570. Here's 555. Here's 570. Oops, not 570, 575. 575 is out here. So that is 2 standard deviations on either side of the mean. So that means it's just going to be the same percentage for 2 standard deviations, or 95.5%. Multiply that by your 6,000, and we end up with 5,730 boxes. The next one, 555 to 580, another easy one. It's only 3 standard deviations from the mean, or 99.7%. We multiply that out and end up with 5,982 boxes. But here comes the tricky one. The tricky one is 550 to 575 grams. And the reason this one is so tricky is because they're not the same number of standard deviations on both sides. It's 3 standard deviations to the left and 2 standard deviations right. Now, our percentage for 3 standard deviations is 99.7%. But that's 99.7% split out equally to the left and the right. Since we only want the left side, we're going to divide that by 2. And when you divide that by 2, we get 49.85%. So we'll have 49.85% of the data on the left. Now our 2 standard deviations to the right is 95.5%. But again, because it's only on the right-hand side, we're going to have to cut that in half, and that's 47.75%. Now, I want to know how much that is. Well, I'm going to the left and the right, so I'm going to add those 2 percentages together. And when I add them together, I get 97.6%. If you multiply 97.6% times 6,000 boxes, what we end up with is 5,856 boxes. So if we were just looking between 550 and 575 grams, we would have 5,856 boxes. These problems were nice, and the reason they were nice is because the boundaries actually fell on the of each group fell on the boundaries of the standard deviations. When this doesn't happen, it takes a little bit more work, and for these problems we use a probability chart. And this problem, in this chart, T represents the number of standard deviations from the center, and P represents 2 things: the percentage of data within that area, or the probability of a number falling in that area as well. So this is a probability as well as a percentage chart. And if you notice, at 1, it's 68.3%, at 2, 95.5%, at 3, 99.7%, and at 4, 99.999. Excuse me, 99.99. That is exactly the same numbers that we are already using in the previous problems. First, let's use this chart to set boundaries when we know the mean and the percentage we are interested in. If the mean is 124 and the standard deviation is 16, and we want the boundaries for 72% of the data, the first thing we're going to do is we're going to find the value of T in the chart for 72%. We need to know how many standard deviations away that is. And the closest number for that is 0.729. So we're going to say that 72% is about 1.1 standard deviations away from the mean. So now what we're going to do is we're simply going to take 1.1 standard deviations. We're going to multiply that by the standard deviation. So we get 17.6. that means 1.1 standard deviation was 16, so 1.1 standard deviations is 17.6. We're simply going to take that and subtract it from the mean and add it to the mean to get our boundaries. So 124 minus 17.6 gives us one boundary of 106.4, and 124 plus 17.6 gives us our second boundary at 141.6. If you want to find the percentage of data between two values, you need to know how many standard deviations away from the mean they are and add or subtract appropriately. As an example, what if I wanted to know what percent of the data is between 128 and 142? The first thing I have to do is I have to figure out how far 142 and 128 are from the mean. 142 minus 128 is, 124 is 18. That's 18 away, but one standard deviation is 16, so it's a little bit more than one standard deviation. How much more? 18 divided by 16 is 1.125 standard deviations. The next one is 128 minus 124, and that is a difference of 4. 4 out of 16 is 0.25 standard deviations. Because these are both on the same side of the mean, I want to subtract those two values, and I end up with 0.875 standard deviations. 0.875 is not in my chart, so I'm going to look at 0.9 standard deviations away. And looking in the chart at 0.9 standard deviations, I find that that is about 63.2%. But keep in mind that 63.2% would be 0.9 standard deviations to both the left and the right. This is all on the right side. So I have to take that and divide it in two. So my final answer is 31.6%. Now let's look at a slightly more complex problem. We're going to follow the steps here. This is what I was doing when I was subtracting to find how many standard deviations away it was from the mean. It's just another way of writing it. The first thing on this problem, though, is that they did not give us the standard deviation, but they did give us the mean and they gave us the range. So you know that x bar was 63. I know the range was 20, which meant that there were 10 on either side. A 10-inch difference on either side. Now, if I want to know the standard deviation, remember there are 4 standard deviations per side. So 10 divided by 4 is 2.5. So 2.5 equals our standard deviation. Now, at this point, we would go straight to what we were doing before. If we wanted to know the percent between 60 and 66, first we would do 66 minus 63. And that is 3, and that's on the right side. And then 3 divided by 2.5 is about 1.2 standard deviations on the right. On the left, it's 63 minus 60, which is also 3. This means we're equally balanced on either side. That means we don't actually have to divide the percentages in half. We can just multiply the percentage and keep it as it goes. If they were different, we would take each percentage, divide it by 2, and then add them together. Now, the percentages for this worked out to be 77%. Looking it up on the chart, 1.2 standard deviations was 0.77. Now, on the next one, we simply would do the same thing that we did on the previous example. The last concept of the day is percentile, and percentile is not the same thing as a percent. On a percentile, if you score in the 85th percentile, it means you did better than 85% of the people taking the test that day. If you scored in the 50th percentile, you're still in the top half. You're better than 50%. Please work the practice problems and then you can check them in class. Thank you.